Hello, my name is Alex Murray, a systems engineer at Scientifica. Thank you for tuning into this video about SciScan 1.1's compatibility with the OME TIFF format and how it can be used. The Open Microscopy Environment is a consortium of academic labs and commercial entities that create open tools to support the organization and management of imaging data. The OME TIFF format includes a structured block of XML as one of the TIFF tags in the header of the image file. The structure of the metadata is defined by the OME XML schema. All TIFF files recorded from SciScan will now include the OME XML metadata in the header as standard. Raw files lack a header to write the metadata into, so instead we write a copy of the XML file in text format and save it alongside the image. To ensure that existing workflows and analysis routines are unaffected by this change, we're going to continue to save a copy of the INI configuration file alongside the data every time an image is recorded. So let's have a quick look at what the XML file actually looks like. I'm going to open it using a program called Notepad++, as this will maintain the XML structure and has useful tools for highlighting the syntax. However, any standard Notepad or text editor will be able to open the file. As you can see, the XML shown here is quite extensive. It contains information not only about the image parameters used, but of the experimenter. So here's my name and my email address. The microscope that we were using to take the images, in this case a Scientifica MP1000. You can include information about the light source, so what type of laser source you were using for the 2-photon excitation, as well as information about the fluorophores you were visualizing on each channel. The most important part of any metadata is the information pertaining to the image itself. Not only do we record the pixel resolution and the number of frames in the image, we also include extra information including the number of slices, in this case as it was a Z-stack image, as well as the number of frames per slice in the recording. All of this can be used to help sort and analyze your data afterwards. That's pretty much it for the raw files. So let's move over to my TIFF example and see how we handle the metadata in them. With the TIFF files, we still record a copy of the configuration file, and we still save a text copy of the metadata, just in case you want to be able to view and edit it without extracting it from the TIFF header. The INI file still contains all of the information that you're used to accompanying a Scientifica TIFF and can continue to be used in any existing workflow. The TIFF file itself will still be editable in any normal TIFF reading software. As you can see here, I can drag it straight into image J and the image opens with no problem. Here's the first frame of my stack. It's a 2-channel image in which the second channel is empty, so I expect there to be no data there. You can see at the top, image J does make use of some of the basic metadata included in the TIFF header. It has the pixel resolution, the number of frames, and the scale. However, there's a lot more information included in the header of the TIFF, and the reason we can't use it now is that you have to open the TIFF file using an OME aware application. Luckily for us, the Open Microscopy environment provides free tools for opening their OME TIFFs in a variety of different programs. The Bioformats Importer plugin can be used with programs such as ImageJ, MATLAB, and other open source image analysis softwares. Now let's try opening the same image using the Bioformats plugin instead. I'll navigate to the plugin, select the TIFF file that I want to open, and immediately I'm presented with this dialog that asks me how I want to handle some of the metadata. First of all, I'll tell it that I'd like to display the metadata so we can see what's stored there. And secondly, as it was a 2-channel image where one of the channels was empty, I'm going to ask it to split the channels. While we wait for the images to open, you can see that it's already opened the metadata as we requested. It has all the same information in the file that I opened earlier, and it can be copy and pasted from here if needed. When the images are finished loading, they'll open as 2 different files, one for channel 0 and one for channel 1. In this case, our data is in channel 0 and channel 1 is empty. Along with the OME XML metadata, you're presented with the standard metadata that's written into the default TIFF header. This information is what ImageJ was originally using to calculate the pixel dimensions and the scale of the image. You can see here now that ImageJ is using much more of the information that's embedded in the OME XML header. It's displaying the number of slices in this Z stack and the number of time slices at each Z plane. That means I can easily go into my plugins menu and run an average for each Z position without having to dig into the metadata and try and figure out how many slices I took per plane. So here is my average stack with all 8 time slices for each Z position averaged together. These features alone are great, but the OME TIFF format really comes into its own when you're trying to store and organize lots of imaging data from different projects, users, or groups, such as in the case of a core imaging facility. A huge benefit of XML is how easily it can be incorporated into a database. This is exactly what OME have done with their OME software, which is also available from their website. OME is a client-server package that allows you to import and save all of your imaging data into a central repository and view and or edit them from any PC given access to the server through the OME client software. OME will allow you to search all of your imaging data at once, and with the OME XML present in the image header, it allows you to filter and search by any parameter saved inside the metadata. OME also includes a bunch of other handy tools for image editing, analysis, and figure preparation. Many programming environments, such as MATLAB, LabVIEW, and Python, have XML handling functionality available. This means that OME-compatible metadata can also easily be used in any custom-written analysis routine. Thank you for watching this short introductory video to our OME TIFF compatibility. If you'd like more information about the plugin and how to use it, please check out the knowledge base.